addition and subtraction rules. In my opinion, you just need to remember two of these. You can remember all of them. The sine of x plus y. The sine of x plus y is equal to the sine of x, the cosine of y plus, now reverse it. Now take the sine of y and take the cosine of x. Another rule you should know is the cosine of x plus y. Here you take the cosine of x and then the cosine of y minus, and now you play the same game with sine. Sine of x times the sine of y. These two you must remember. Now, remember that if you have a minus b, this is understood to be a minus a positive b. You have every right to change both of those. This becomes a plus negative b. So if you have subtraction, you can get it to be addition. And generally, when you have two symbols next to one another, you just separate them with brackets. Probably what I should have done there as well. Okay, so again, a take away b is a plus a negative b. And if you were given the sign of x minus y, you can use this first rule if it were a plus. So then this becomes the sign of x plus a negative y. So the two angles are x and negative y. I'm using the right-hand side now. You get the sine of the first angle, x, times the cosine of the second angle, which is y. Plus, now you reverse it. Now you get the sine of the second angle times the cosine of the first angle. And then you say, well, sine x is sine x, but cosine of y, negative y, is just cosine of y. With sine, the minus comes out in front. So it becomes minus sine y cosine x. Okay, here is the third identity. You either have to memorize or derive. Now, if you were asked for the cosine of x minus y, you can think cosine of x plus negative y. Why are you thinking this? Because you only remembered these two rules. And in cosine, you get the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. So, cosine of x minus y is equal to this. So let's clean that up. Cosine of x stays cosine of x, and cosine of negative y is cosine of y, minus the sine of x stays the sine of x, but the sine of negative y, the negative comes out in front, which makes this minus, or subtraction, addition, and then you have sine of y. Here is the fourth one. Here is the fourth one. Okay, you need to have those. Now, the last two, for tangent, those I never remember, nor do I even derive. There's a lot to learn in trigonometry. trigonometry. The goal is to learn or memorize as little as possible and do well. I mean, don't go and learn nothing and get zeros on your test. The goal is to do well and to remember as little as possible. So, for example, if somebody asked me what the tangent of x plus y was, I would think the sine of x plus y divided by the cosine of x plus y. And then, well, the answer is right on top. I would divide those two. That is, I would divide these two. And that's the formula I would use. I would say it's sine x cosine y plus sine y cosine x over cosine x cosine y minus sine x sine y. You can use this formula and you'll never be wrong. And I didn't memorize it at all. All I memorized was that tangent is sine over cosine. Okay, but the formal answer, and again, you never ever have to use it unless for some very strange reason, in my opinion, your teacher says straight out, you can't use the formula I just erased. Okay, it's the tangent of x times the tangent of y, but that's not going to be true. It's plus. The tangent of x plus the tangent of y over 1 minus tan x tan y, I guess. And if you have the tangent of x minus y, well, you could just divide those two, sine of x minus y, divided by the cosine of x minus y. But in terms of tangents, you get tangent x minus tangent y divided by 1 plus tangent x tangent of y. So these are 6 rules that your textbook wants you to know. You can get away for real with just knowing these two, and then to get these two by using the trick that I showed you. But even if you have to remember those two in the bottom, so far you remembered the 4 that have x's, then you don't really need to memorize these two. You can get away with never, ever using those two. You can just say tan of x plus y is sine of x plus y divided by the cosine of x plus y. And we memorize those rules. That are 2 top rules. Okay, here it's the sine of x minus y divided by the cosine of x minus y, which is the 2 bottom rules. You never ever have to remember these 2 middle ones. Never. Never. Okay. I don't. I had to look that one up in my book right now. Personally, I just remembered the first 2. And I know that sine of negative x is negative sine x, and cosine of negative x is cosine of x. Now, remember that we know everything about a 30-degree angle, a 45-degree angle, and a 60-degree angle, and for the record, 0 degrees and 90 degrees. You know everything about those angles. For example, here is a 30, 60, 90-degree angle. Opposite 30 is 1, hypotenuse is 2, opposite 60 square root of 3. That is, we know the 6 trig functions of 30 and 60. The same thing with 45. So 45 degree, 45 degree, 90 degree right triangle. 1, 1, square root of 2. We know the sine of 45 degrees, the cosine of 45 degrees, the tangent, the cosecant. Now, when it comes to 0 and 90, well, here's the sine graph. Here's 0. Here's 180. The 90 is in the middle. The highest is 1. The lowest is negative 1. The sine of 0 is 0. And the sine of 90 is 1. And when it comes to the cosine, here's 90 right here, and here's 0 degrees right there. The cosine of 0 is 1, and the cosine of 90 is 0. And if you want tangent, I would just use the sine and the cosine. What's the tangent of 0 degrees? Well, it's the sine of 0 over the cosine of 0. I wouldn't bother drawing a tangent graph. The sine of 0 is 0. The cosine of 0 is 1. 0 divided by 1 is 0. And you can do the same for 90 degrees. Okay. But now, we can even do more. If the reference angles are 30 or 45 or 60, we can deal with it. We can tell what the sine and cosine, etc. of angles that have reference angles that are 30 or 45 or 60. For example, if you're in the first quadrant and the reference angle is 30 degrees, well then you're 30 degrees. But if you're in the second quadrant and your reference angle is 30 degrees, then you are 150 degrees. Why? Because if you make the mistake and you go too far, you go to 180 and then you say, oops, I went too far, I have to go back 30. Well, then you're 150. For 30 degrees, it's also the same as like being 150. If you are in the third quadrant, if you're here and you're 30 degrees reference angle, well then you're 180 plus 30 more. That's 210. 210. If you're in the fourth quadrant and your reference angle is 30 degrees, well, one way of getting to right here, one way of getting right here is to go too far, to go 360, and then to turn around and go back 30. That gives us 330. 330. Okay, and having these numbers in front of us are very important to do the next set of exercises. Having these in front of us is very important to do in the next exercise. And in front of us can even mean just in our head. For 45 degrees, well, if you're in quadrant 1 and the reference angle is 45, well then you're 45. But what if you're in quadrant 2? If this angle here is 45, how big is this angle? Well, go too far, go to 180, and then go back 45. 180 minus 45 is 135. 135. In quadrant number 3, if your reference angle 45 degrees, well then this is 45. You can go 180 and then 45 more to get to your desired angle. Well, it turns out that 180 plus 45 is 225. 225. What if you're in the last quadrant, quadrant number 4, and your reference angle is 45? That is, your angle goes somewhere to quadrant 4. So I went to quadrant 4, and I draw my line. Always go to the x-axis, right here. So here's my reference angle, is 45 degrees. My question is, well, how big is this angle? Well, there's one nice way of figuring it out. You can go more than you want. You can go to 360. That clearly didn't bring you to the angle you wanted, so then you have to go back 45 degrees. All I'm saying is, if you want to go this far, you have two options. You can go that way, or you can go past where you wanted, 360 degrees, and then come back 45. And that brings you right there. And 360 minus 45 is 315. To save a little time, if you're 60 degrees, you can be 120 or 240 or 330. In quadrant number 4, 330. Oh, I don't believe that. How about 320? And for 0, you can figure out, using the sine and cosine graphs, you can find multiples of 90. 0, 90, 180, 270, 360, etc. 270. Okay, so we didn't need the last column because, or the last row, because 90 was included in the first row. 0, 90, 180. All right. So now that we have this table, whether you kind of memorized it or what have you, you have it. Now, if somebody were to ask you, what is the sine of 15 degrees? What is the sine of 15 degrees? And we're doing this without a calculator. Find the sine of 15 degrees without a calculator. And you say, oh my, we know nothing about 15 degrees. So what you want to do is, using these numbers in the table, is you want to find two numbers that either add up to 15 degrees or subtract to 15 degrees. And although there's a number of them, it turns out that 45 minus 30 is 15. So this is the same as the sine of 45 minus 30 degrees. Now remember, so let me actually write it down here. It's the sine of 45 degrees minus 30 degrees. It's the sine of x minus y. Okay, but what is the sine of x minus y? It's the sine of x times the cosine of y minus the sine of y, the cosine of x. X is 45 and y is 30. So we get the sine of 45 degrees times the cosine of 30 degrees, minus the sine of y, which is 30, times the cosine of x, which is 45. And coming down here, the nice thing is we know everything about 30 and 45. Let me just draw it, please. 30 is 1, 2 square root of 3. And 45 is 1 square root of 2. So first we want to sine of 45 degrees, which is opposite over hypotenuse. It's 1 over the square root of 2 times the cosine of 30. Cosine of 30 is adjacent over hypotenuse. It's the square root of 3 over 2 minus the sine of 30. Well, sine of 30 is opposite over hypotenuse. It's a half times the cosine of 45. It's adjacent over hypotenuse. It's 1 over the square root of 2. Okay, so coincidentally, the denominators are the same. Square root of 2 times 2 and 2 times square root of 2. I'll write the 2 first. 2 square root of 2. So the numerator gets subtracted. 1 times square root of 3 is square root of 3. 1 times 1 is 1. Now, final answer should not have radicals in the bottom. So multiply the top and the bottom by square root of 2. The numerator is the square root of 2 times the square root of 3 take away 1, and the bottom is 4. So square root of 2 times square root of 2 is 2. That's why we multiply by square root of 2 over here to get rid of the square root sign. Square root of 2 times square root of 2 is 2, times the other 2 is 4. And there is your exact answer. You put that into a calculator, it will not, if you put sine of 15 degrees in a calculator, it wouldn't give you this answer. No way would it give you that answer. That is how you use the sum and difference rules. Okay, let's try another one. Let's leave our tables up there. That is the 2 triangles, which I guess one of them was erased. Sorry. Let's erase both of them because I drew on them. Now I want to do the sine of 75 degrees. I want to calculate the sine of 75 degrees. So what you need to do is look at those numbers and see if any pair of numbers on this table either add up to or subtract out to 75. Because if they do, we're done. Well, not done, but we have the main part done. We know what angles to use. So instead of using sines, let's say cosine. The cosine of 75 degrees. Well, can you think of 2 numbers that either add up to or subtract down to 75? Okay, now, initially, I was thinking that 225 minus 150 is 75. Or, you can add 30 and 45. Let's do it both ways. This is the same as cosine of 30 plus 45. Okay, well, what is the rule? That is, what is the rule for cosine of x plus y? The rule for cosine of x plus y is the cosine of x, the cosine of y, minus the sine of x times the sine of y, where x is 30 and y is 45. So you get the cosine of 30 times the cosine of 45 degrees. Let's move this triangle out of the way. Minus the sine of 30 degrees times the sine of 45 degrees. And we definitely need the 45 degree triangle. 1, 1, square root of 2. Okay, coming down here, the cosine of 30. Cosine is adjacent over hypotenuse. Square root of 3 over 2 times the cosine of 45. Cosine is adjacent, which is 1, divided by the hypotenuse. 1 over the square root of 2. Minus. The sine of 30 degrees is opposite over hypotenuse. It's a half. Times the sine of 45 degrees. It's opposite over hypotenuse. 1 over square root of 2. Once again, oh, I see. Okay, once again, the denominators are the same. The numerator, square root of 3 minus 1. If you multiply the bottom by square root of 2, you have to multiply the top by square root of 2. So the top is square root of 2 times the square root of 3 minus 1. The bottom is, well, square root of 2 times square root of 2 is 2, times another 2 is 4. Now you may say, oh my, we got the same answer as before. Of course. Remember I told you the sine of 15 degrees. I told you that the sine of x is the same as the cosine of 90 minus x. Well, x is 15. What's 90 minus 15? 75. So if you were asked to do this problem as well as this one, you should thank your teacher, because you don't have to do this one. Whatever you get for this, you put down for that as well. If you say this was 0.3, well then this here is also, you should say 0.3. But in reality, it's that answer. Okay. Square root of 2 times the square root of 3 minus 1 over 4. Okay, like I said, we're going to do this one twice. We're going to do this one twice because you didn't necessarily have to find two angles. It added up to 75. You could have found two angles that subtract out to 75. Like I said, in fact, that's what I was saying. Okay, let's erase all of this and move on. Okay. We have the answer in the top corner. Make sure we get that same answer. 30, 60, 1, 2, square root of 3, 45, 45, 90, 1, 1, square root of 2. Okay. Well, 275 is the same as 225 minus 150. That is, it's the cosine of 225 minus 150. And let's see the rule we're going to use. Here we're going to use the rule for the cosine of x minus y. And that rule is just going to have the plus in the middle. This is cosine of x times cosine of y plus the sine of x times the sine of y. So we get the cosine of x, which is 225, times the cosine of y, which is 150, plus the sine of x, which is 225, times the sine of y, which is 150. Okay. And since I need the space, I'm going to erase this last line. But that last line is nothing more than the formula that you're going to need to be able to write down on the test from memory or however. Okay, what is the cosine of 225? Well, 225 is 180 and 45 more. Now, when it comes to 45, it's 1, 1, square root of 2. Except the top 1 since you go to the left, it's minus, and the other one, since you go down, it's minus. Okay, so the cosine, so you can take the cosine of this angle using that triangle. The cosine is adjacent over hypotenuse. It's -1 over the square root of 2. And now we want to multiply this by the cosine of 150. Well, 150 is in quadrant 2. If you went 30 more, you would have gone to 180. That is, the reference angle is 30. Opposite 30 is 1, hypotenuse is 2, adjacent is square root of 3. Except, since this is going up, it's plus, and this is going to the left, it's minus. If you want the cosine of 30, it's adjacent over hypotenuse. It's negative the square root of 3 over 2. Plus, now we want the sine of 225. Well, we kind of have that. The sine of 225, here's our triangle right here. The sine is opposite over hypotenuse. It is -1 over the square root of 2. Now, what's the sine of 150? Well, the triangle is in front of us. It's this triangle here. After all, it says 150. And the sine is a third of 150 is opposite over hypotenuse. It's a half. Okay. It's a half. It's a half. So let's figure this out. Let's figure out this piece. Well, a negative times a negative is positive. 1 times square root of 3 is square root of 3. The square root of 2 in the bottom times 2 is 2 square root of 2's. Plus, this minus comes out as minus. 1 times 1 is 1. 2 times square root of 2 times 2 is 2 square root of 2. And we did this problem 3 times now. It turns out it's square root of 2 times the square root of 3 minus 1 over 4. Exactly what we've been getting. Exactly what we've been getting. Okay, so sometimes you can use the sum rule, sometimes you can, for the same angle, you can use the difference rule. Either one works. Sometimes. Sometimes you can use one or the other. Sometimes you might only be able to use one of them. If you need to have that table written down in your mind, whatever, so then you can figure it out. For example, if you are asked to find the cosine of pi over 12, well, we kind of just did this one. 180 divided by 12 is 15 degrees. Okay, so you should think of this maybe as a cosine of 45 minus 30. And then use the rule. Okay, I'm not going to keep working these out for you. This becomes, I'll write down what you need to do. The cosine of 45 degrees times the cosine of 30 degrees plus, right? Yeah, it's going to be plus. Plus the sine of 45 degrees times the sine of 30 degrees. This, and that, you know how to calculate, so you're on your own there. Okay, your job is to know these rules. Somebody asks you to find the tangent of 105 degrees. you should immediately think of, oh, 105 is 60 plus 45. And then remember that the tangent of x plus y is whatever it is. Okay, if you want to use it, you can. It's the tangent of x plus the tangent of y over, I think, 1 minus tan x tan y. Yeah. So, x is 60 and y is 45. So you get the tangent of x, the tangent of 60, which you can calculate, plus the tangent of y, where y is 45. And this all gets divided by 1 minus the tangent of x times the tangent of y. It's 1 minus this times that. Okay. And then that you can work out. Using the 60-degree triangle, 30, 60, 90-degree triangle, you can find the tangent of 60. Using the 45-degree triangle, you can find the tangent of 45 degrees. Or if you prefer, and it's a bit longer, but you don't have to memorize additional rules, you could have said the sine of 105 is equal to the tangent of 105. You could have said that the tangent of 105 degrees is the sine of 105 degrees divided by the cosine of 105 degrees. And the sine of 105 is the sine of 45 plus 60. And the cosine of 105, you're going to think of as the cosine of 45 plus 60 degrees. And then you use the sum rule for sine. Use the cosine rule, use the sum rule for cosine. Okay, that's an alternative way of doing it. The nice thing is you don't have to remember yet another formula. You don't have to memorize another formula. Now, here's an interesting concept. I proved to you that the sine of 90 degrees minus x is the same as the cosine of x. Well, we can do it another way. We can prove it. Remember, the sine of a minus b this is the sine of A, the cosine of B, minus the sine of B, cosine of A. So, if you have the sine of 90 minus x, A is 90, B is x. So we have the sine of 90, cosine of x, minus the sine of x, cosine of 90. Well, the sine of 90 degrees, well, here's 90. It's 1. This is 1 times cosine of x. And that piece is cosine of x minus the sine of x times the cosine of 90. Well, you should start realizing when sine is 1 or negative 1, cosine is 0. And where cosine is 1 or negative 1, sine is 0. Where one of them is 1 or negative 1, the other one is 0. Where one of them is 0, the other one is 1 or negative 1. The cosine of 90 degrees is 0. And sine x times 0 is 0. So we're taking away 0, and that gives us cosine x. The sine of 90 minus x is cosine of x. Okay, so that's a fair problem to put on the exam. Using the difference rule, show that this equals that using the difference rule, the subtraction rule. Sum rule, subtraction rule. nice little problem. Suppose you have this. Suppose you have this. And I tell you, this is the right angle, and that's the right angle. Excuse me. Excuse me. I tell you, that's the right angle. I tell you, this angle is x. And I tell you this angle is y, and I tell you this angle is z. Want us to conclude that x plus y is equal to z. Okay. Now, I guess I need to prove something first. I want to show you that opposite angles are equal. If I call this angle x, then this, remember, this whole angle is 180. This whole angle is 180. It's a straight line. Well then, if part of it I'm calling x, then the rest of it must be 100 minus x. Now, let's look at it from this point of view. This angle is 180. If this piece is x, then just this piece, it must be 180 minus x. Okay, let's erase some of this. Mark it down if I'm going to erase. Okay, so now let us consider this angle. It's 180. Well, if this piece is 180 minus x, then this little piece must be x. Because if you have 180 minus x, and you want to add something to get to 180, you better add that to x. Okay. What we just shown was opposite angles are equal. This is x and this is x, the opposite. This is 180 minus x. This is also 180 minus x. Opposite angles are equal. It's not because your teacher told you that. It never is that, folks. It's because you can prove it. Okay, so, for example, if I call this angle A, well then this is also angle A. And if I call this angle B, well then this angle must also be angle B. Okay. Now let's see what we have. We know that we have three triangles. 1, 2, and 3. And in each one of them, the angles add up to 180. Since one angle in triangle 1 is 90, then the other two angles must add up to the other 90. Let's go on to triangle 3. Since we have a right angle, then the other two angles, y plus b, must add up to 180. Okay. Now, in triangle number 2, we know that in triangle 2 that a plus b plus z is 180. Okay, so let's add up these two. We have that x plus y plus a plus b is 180. So something plus a plus b equals 180. Something plus a plus b is 180. These things must be the same. V plus a plus b is 180. If I were to subtract these two equations, I would get x plus y minus z, the a's plus b's cancel out, equals 0. Right here now. If x plus y minus z is 0, I add z to both sides, and I get that x plus y is z. And that's what we were asked to show. You really should be able to do that. I just wrote down everything that I knew. Triangle 1 told me that x plus a was 90. Triangle number 3 told me that y plus b is 180. And triangle number 3 told me that x plus y plus z was 180. A plus b plus something is 180. There's only one thing to add to a plus b to get 180. And on one hand, we're calling it z. On the other hand, we're saying something plus a plus b is 180. This time we're calling that something x plus y. They must be equal. Alright, x plus y equals z. That finishes this section. Good luck with it.